Welcome everyone to the deep dive. Today we're diving into something really exciting, a topic that's, well, fundamentally changing how we explore the cosmos. We're talking about artificial intelligence and its impact on space exploration. It really feels like we're at this amazing crossroads,
Yeah.
the digital age meeting our deepest cosmic ambitions, and AI. It's not science fiction anymore. It's becoming, well, essential.
That's absolutely right. For the longest time, AI in space seemed like, something out of a movie. But over the next decade or so, we're going to see it shift from just being a helpful tool to being a truly indispensable co-pilot. It's not just about the cool things AI can do anymore. It's becoming a necessity. It's why we'll be able to push beyond our current boundaries to explore in ways we've, frankly, only dreamed about until now.
Yeah, and when you think about the scale of space, I mean, the sheer vastness, it becomes obvious why we need it, doesn't it? We're talking distances where light takes minutes or hours, sometimes years to cross. Our old methods, the rigid plans, everything done manually, needing someone back on Earth watching constantly, they just don't cut it anymore, not for where we want to go.
Exactly. Venturing out to the outer planets, thinking about interstellar probes eventually. That communication lag, the time delay, it makes continuous human control basically impossible, or at least incredibly impractical.
And that's where AI steps in, right, to bridge that gap.
Precisely. It hits those key problems head on. The communication delays, the incredible complexity of modern missions, the absolute flood of data we're getting back. AI isn't just a nice to have anymore, it's foundational. It's the enabling tech for this whole next chapter of exploring space.
So that's our mission for this deep dive then. We want to pull out the really crucial insights from our sources on how AI is set to redefine what we can actually do out there. We'll dig into the key areas, automation, making things more efficient, helping us make smarter decisions, and even speeding up scientific discovery itself. So get ready, because the future of space, it's happening now, and AI is right at the heart of it.
It really is. We're moving past AI as just an add-on. It's becoming integral. It's letting us go further, explore more deeply, and learn faster than ever before. It's fundamentally changing our reach across the cosmos.
Okay, let's unpack that first big idea, autonomous systems. And this isn't just like robots doing simple stuff. We're talking about spacecraft becoming genuinely self-reliant, making their own decisions millions of miles away. Why is that so critical as we push further out?
It really boils down to the tyranny of distance, as you said. When missions go way out there, Mars, sure. But think Jupiter's moons, Saturn's moons, maybe even interstellar someday. The signal delays are huge. Minutes, sometimes hours, just for a command to get there. So real-time control. Like someone on Earth with a joystick driving a rover, forget it. It's just not feasible.
Right, the lag makes it impossible.
Yeah, so AI allows these spacecraft to act independently, to make those split-second decisions on the spot. It's almost like embedding a piece of mission control right into the machine itself.
That makes total sense. So, okay, AI-powered rovers and landers, we've seen amazing things from Perseverance on Mars already, right? It's just some basic autonomous navigation, avoiding rocks and stuff. But what's the big jump we're expecting soon? How does AI make them truly smart explorers, not just remote-controlled cars?
Well, the current abilities are great. They're foundational. Perseverance can navigate around things right in front of it, maybe prioritize a target within a plan humans gave it. But the next generation, they'll use much more advanced AI. Think neural networks. They'll actually learn from their environment in a much deeper way than today's rule-based systems. And that allows for what we call true dynamic adaptation.
Dynamic adaptation. Okay, that sounds like a big deal, a real game changer. How does that play out on, say, the surface of Mars? What does it do?
Well, imagine a rover that's not just sticking to a pre-planned route or dodging boulders. It's constantly processing this huge stream of data from its sensors, cameras, building 3D maps, spectrometers, analyzing rock composition, weather sensors. And it uses things like convolutional neural networks for perception and reinforcement learning to sort of think through different actions. So it can react dynamically to stuff it wasn't expecting. Maybe a sudden dust storm kicks up, or maybe it finds some really interesting terrain, something that hints at past water, maybe. Instead of waiting hours for instructions, the AI could decide itself to change course, to go investigate that interesting feature right now, maybe even use a tool it was saving for later.
Wow. So it can prioritize on its own.
Exactly. Or if it encounters something dangerous like really soft ground or a steep drop-off, it can figure out a safer, maybe more energy-efficient way around all by itself. It's about giving the machine a kind of Well, almost a curiosity, something beyond just following programmed steps.
That's incredible. It's like having a really smart, really quick-thinking geologist right there on Mars,
Yeah.
making calls that would take us days to relay back and forth. And this ties into another key thing for long missions, doesn't it? Self-repair and maintenance. Stuff breaks, especially over years in space. How does AI stop a small glitch turning into, mission failure?
Right, that's another huge area. AI will allow spacecraft to monitor their own health proactively. They can diagnose problems with amazing accuracy and sometimes even initiate minor repairs or, maybe more often, clever workarounds. We're not necessarily talking about robots with wrenches yet.
Okay.
It's more about using deep learning and anomaly detection. These algorithms sift through data from thousands of sensors all over the spacecraft. They're looking for tiny, subtle signs that something isn't quite right long before it becomes a serious problem.
So it's like preventative medicine for spacecraft, catching the whisper before it becomes a scream.
That's a great way to put it, yeah. Detecting those tiny anomalies early, maybe a slight dip in power from one solar panel, or a temperature fluctuation in a component that's barely noticeable. The AI sees that pattern, flags it, and can trigger adjustments. It might reroute power, maybe throttle back a component to reduce stress, or even activate some kind of software patch. This massively improves mission lifespan, which is crucial when you've spent billions sending something to Jupiter or beyond. It keeps these incredibly expensive machines working longer by tackling problems when they're small, sometimes stopping a critical failure entirely.
That's a huge deal for cost and just getting the science done. It makes the whole investment worthwhile. And it's not just for probes way out there, is it?
No.
What about closer to home? Humans in space, the ISS, future moon bases. How does AI become our orbital teammate?
Yeah, absolutely. On space stations, future habitats on the moon or Mars, AI is going to evolve into genuine robotic assistants. Real crewmates. We've seen early glimpses like Simon on the ISS, the little floating AI companion.
Yeah, Simon, the floating head thing. Kind of cool, but seemed mostly informational, right?
It was a first step, yeah. Mostly interactive information, maybe some psychological support. But future AI companions, they'll be much more sophisticated and, crucially, much more physically capable. They'll manage vital life support, constantly tweaking air quality, humidity, temperature, radiation levels. They'll monitor astronaut health proactively, not just reacting if someone gets sick, but looking for subtle biometric changes, heart rate patterns, sleep quality that might signal stress, fatigue, or an oncoming issue. They could flag it for the crew or mission control.
Okay, that's impressive. But you said physically capable. What kind of complex physical jobs could they do? Things that maybe free up astronaut time or reduce risk?
That's where it gets really exciting. Think about tasks that currently need astronauts to do dangerous spacewalks.
Like building stuff outside or repairs. That's always seemed incredibly risky. The radiation, micrometeoroids.
Exactly. Imagine highly dexterous robotic arms controlled by AI assembling large sections of a new space station module by module, or deploying huge complex solar arrays that are just too fiddly or large for humans in bulky suits to handle easily, or performing precise repairs on the station's exterior after, say, a small debris impact. These AI robots could do that work, maybe autonomously or semi-autonomously.
Wow. That would massively cut down on EVAs, wouldn't it?
Dramatically. It minimizes human exposure to all those risks, the radiation, the vacuum, temperature extremes, and it frees up that incredibly valuable astronaut time. They can focus on the science, the experiments, the things that really need human insight and adaptability. It's a fundamental shift. Humans and AI working together, making space safer and way more productive for people.
That's a perfect segue, actually, because AI isn't just about the robots and the physical stuff. It's also the brain behind the whole operation, right?
Yeah.
Space missions are just mind-bogglingly complex
And expensive.
and risky. So how does AI help wrangle all that complexity, especially right at the beginning, in the planning stages?
This is really where AI's analytical power shines. It acts like a super intelligent, hyper-efficient strategic planner. Its strength is chewing through massive data sets and optimizing systems with tons of variables. And that's exactly what mission planning is. Billions of data points, countless factors, orbital mechanics, fuel needs, payload weight, launch timing. AI can sift through all that, find patterns and optimal solutions humans might never spot.
Okay, let's start with getting off the ground. Trajectory and launch optimization. Launches seem like such a precise dance. Every gram of fuel, every second counts. How will machine learning shake that up, make it safer, more efficient?
It'll revolutionize launch dynamics pretty much end to end. Right now, launch windows rely on lots of human calculation, historical data. It's precise, but limited by how fast humans can crunch numbers. Future AI systems, using sophisticated machine learning, will analyze real-time atmospheric data, super granular fuel burn rates, the exact payload configuration, all with incredible detail. This lets them pick the absolute best launch window for energy efficiency and safety, sometimes finding opportunities missed by old methods. It's not just about a safe liftoff, it's about getting into orbit or onto that specific interplanetary path, using the absolute minimum energy, saving crucial fuel and time.
And for those long interplanetary journeys, millions of miles, those small savings must add up massively, right?
Hugely. When you're talking interplanetary trajectories, you're dealing with complex gravity assists, incredibly precise orbital maneuvers. AI systems, maybe like the ones DeepMind develops for complex problem solving, they can find optimal paths through that gravitational spaghetti that are almost, well, counterintuitive to us. By finding really subtle gravity boosts from planets or moons, optimizing every tiny aspect of the orbit, they could cut travel times to places like Jupiter or Saturn by weeks, maybe even months.
Weeks or months. That's huge. That impacts everything cost. Crew health on future missions,
Yeah.
system longevity.
Absolutely. Massive implications for mission viability.
Okay, speaking of things in orbit, satellite constellation management. With thousands of satellites going up, things like Starlink, the space around Earth must be getting seriously crowded.
Yeah.
How does AI stop it becoming a demolition derby up there?
It is getting crowded, yeah. And without AI, it would become totally unmanageable. You'd risk the Kessler syndrome, where collisions create debris, causing more collisions. A total disaster. With tens of thousands of satellites planned, AI is non-negotiable for managing that traffic and preventing collisions. Manual tracking just can't keep up.
So AI is basically space traffic control, preventing cosmic fender benders. It's scary to think one mistake up there could create junk that lasts for generations.
That's exactly its role. These autonomous systems, using real-time data from tracking networks worldwide, constantly monitor every satellite's position and speed. They run predictive algorithms, spotting potential close calls hours, even days ahead. Then, instead of waiting for a human command, the AI itself initiates tiny, precise thruster burns, sometimes just changing velocity by centimeters per second to nudge satellites safely out of the way.
Automated collision avoidance.
Yeah. And beyond just avoiding crashes, AI optimizes their operations too, making sure they communicate efficiently, repositioning them for best coverage, and this is critical, ensuring they deorbit safely at the end of their life, burning up instead of becoming more junk. It takes humans out of the loop for routine management, freeing up ground control for the really complex stuff.
That's a relief, knowing there's a smart system keeping orbital lanes clear. Now, shifting up a level. Strategy, resource allocation, budgets. Space is expensive. How does AI help agencies and companies make the smartest bets with their money?
This is huge for making smart decisions in a field where budgets are tight and the stakes are sky high. Agencies and companies, they have limited funds, they need to pick winners. AI helps them allocate those resources across many potential missions. AI algorithms can run simulations like almost infinite simulations of different mission concepts. They assess the risks with incredible accuracy, project the costs down to the nuts and bolts, factoring in potential failures or delays.
So it's like having a superpowered financial analyst and risk manager rolled into one, specifically for space missions, predicting outcomes and optimizing the investment.
Pretty much. By running these complex sims and analyzing historical data from every mission ever flown, successes and failures, AI guides those big strategic choices. It helps ensure money goes to projects with the best chance of success, the highest scientific return, or the best commercial payoff. It can flag potential budget overruns or schedule slips way ahead of time, allowing for adjustments. It lets organizations make really smart, data-driven bets on the future of space, maximizing the bang for every buck and boosting the overall success rate. It optimizes the whole portfolio.
Okay, let's talk deep space again, these truly cosmic distances. Light takes ages to travel. How does AI help us navigate and communicate across those huge gulfs? Because, yeah, your phone's GPS isn't going to work out past Mars, is it?
Definitely not. You've nailed the core problem. The sheer scale means Earth-based systems are useless. Signals are too weak, delays too long. We need completely different ways for spacecraft to know where they are and talk to us. AI is key to that.
So star-based navigation with AI enhancement. What does it actually mean? It sounds cooler than just a simple star tracker. Is it like using stars as landmarks?
It's way more sophisticated than that, yeah. AI dramatically boosts stellar navigation. It allows probes to use celestial objects as a kind of galactic GPS. We're talking about precisely mapping the positions of things like pulsars.
Pulsars. Those are the spinning neutron stars, right? The ones that pulse radio waves.
Exactly,
Yeah.
like cosmic lighthouses. Each one has a unique, incredibly stable timing signal. By detecting these pulses from multiple pulsars, correlating their timing with known patterns in the spacecraft's own motion, the onboard AI can triangulate its position with amazing accuracy, even millions or billions of miles from Earth.
Wow, triangulating using cosmic beacons.
Yeah, and you combine that with recognizing familiar star constellations, and then you add advanced AI like reinforcement learning. The spacecraft can constantly update its position, correct tiny course deviations in real time, with minimal or even zero input from Earth. That self-reliance is vital for journeys lasting decades. A course correction command from Earth could take days to arrive, useless for immediate adjustments.
That cuts the cord from ground control for navigation, which must also be essential for handling communications, right? Sending data back across light years. That sounds incredibly hard. Bandwidth must be ridiculously precious.
It's a monumental challenge, maybe one of the biggest for truly interstellar missions. Even at light speed, signals take forever and get incredibly faint and noisy. Every single bit of data is precious. AI is set to revolutionize how we handle that. It intelligently optimizes how data is compressed and transmitted over these vast distances. And it's not just standard file compression, it's about smart data management, prioritization.
So the AI basically acts like an editor on board, deciding what's the most important news to send back first. That seems critical when you can't just stream everything.
Precisely. Imagine a probe finds something totally unexpected, a weird geological feature, a strange atmospheric reading, maybe even a potential biosignature. Instead of just dumping all the raw sensor data, which could take months to transmit, the AI analyzes it right there, using pattern recognition, anomaly detection. It identifies the most scientifically valuable bits. Maybe just 1% of the data is truly groundbreaking. Then it prioritizes sending that back, maybe summarized, highly compressed. This means mission control gets the most important discoveries way faster, without getting swamped by routine data. It massively speeds up discovery across those huge distances.
That's brilliant. A cosmic filter, picking the signal from the noise. And what about fixing the noise itself? Cosmic interference must be a nightmare for signals traveling that far. Static, radiation.
Oh, it's constant. Data gets mangled traveling through space. Solar flares, cosmic rays, interstellar gas. It all distorts and fragments the signal. AI plays an absolutely crucial role here in error correction and signal analysis. It pulls meaningful data out of what could otherwise be just static.
So it can actually repair corrupted data that got damaged on its long journey home.
Yes, effectively. Advanced neural networks and sophisticated signal processing algorithms can reconstruct images that are missing pieces. They can analyze spectral data, the light signatures telling us about chemistry, even if it's distorted. They can piece together broken telemetry packets. For example, if part of a crucial image gets lost, the AI, knowing what celestial objects usually look like, can intelligently fill in the gaps, often with remarkable accuracy.
Wow.
It means we don't lose vital discoveries just because the signal had a rough trip. The AI acts like a master decipherer, cleaning up the signal, ensuring we get the clearest possible picture from our distant explorers, no matter how noisy space is. It makes sure those billion-dollar investments actually deliver the data they were sent to get.
Okay, so the universe is throwing data at us like never before. Our telescopes, our probes, they're generating this absolute flood of information. But that's a problem in itself, isn't it? It's just too much for humans to sift through manually. This is where AI steps in as our essential cosmic analyst, right? To actually find the needles in the haystack.
It's more than essential, it's the only way forward, really. Without AI, we'd literally drown in data. We'd miss huge discoveries just because we couldn't process it all. AI is that tireless analyst. It finds patterns, anomalies, subtle clues that humans, with our biases and limits, might just overlook.
Let's talk exoplanets.
Yeah.
Finding planets around other stars. Telescopes like Kepler and TESS have found thousands already, which is amazing. It changed our whole view of the galaxy. But AI takes it way further than just counting them, doesn't it? Helps us understand what they're like.
Absolutely. Kepler and TESS are phenomenal planet finders, generating terabytes of data. AI automates and refines the search on a massive scale. AI models now scan those light curves, the brightness data from distant stars automatically flagging the tiniest dips in light that mean a planet might have passed in front. Before AI, astronomers visually checked charts or wrote specific scripts that could miss things. Now AI can churn through years of data in minutes, spotting potential planets that human eyes would just skip over in the noise.
Okay, finding them faster is great. But the really big question, the profound one, is finding signs of life out there. How does AI get us closer to that?
That's the next frontier, and where AI gets really powerful. It's not just about finding a planet, it's about analyzing its atmosphere. Next-gen AI will analyze the spectroscopic data, the light fingerprint coming from these exoplanet atmospheres. It looks for specific chemical combinations that might hint at life, things like oxygen and methane together, which on Earth are produced by biology. Or finding water vapor. AI can sift through incredibly complex spectral data looking for these biosignatures. It dramatically speeds up the search, moving us from just cataloging planets to actually assessing their potential habitability and looking for those tantalizing signs of life.
Mind-boggling. An AI spotting potential life from light years away. Okay, shifting scale, mapping the universe itself, understanding its structure. We have incredibly powerful tools like the James Webb Space Telescope giving us these stunning deep images. How does AI help us make sense of those? See things we couldn't before.
JWST is incredible, yes. But even its images have noise, faint signals, huge complexity. AI is critical for processing that data. It uses sophisticated algorithms for denoising, for enhancing the images. It filters out the background fuzz and boosts the faint light from incredibly distant galaxies billions of light years away.
So it literally makes the invisible visible, peeling back layers of the cosmos.
In a very real sense, yes. By cleaning up the data, AI lets us spot galaxies so faint they'd otherwise be lost. It helps us trace how the universe evolved over billions of years. It can precisely measure the expansion of the universe by analyzing the redshift of countless galaxies, how their light is stretched as they move away. That's a monumental data task. And maybe coolest of all, AI can help uncover structures that are almost impossible to see otherwise. Like the faint filaments of dark matter that form the universe's underlying scaffolding. The cosmic web, it's literally revealing the hidden architecture of the universe.
Wow, that changes everything. And finally, let's bring it closer again. Astrobiology. Hunting for life within our own solar system. We have missions targeting places like Mars, Europa, and Enceladus prime candidates. How is AI on the front lines there, analyzing samples, looking for microbes?
This is one of the most exciting applications right now as our landers and orbiters gather data chemical analysis of soil, sampling water plumes, tasting the atmosphere. AI is right there doing the initial analysis. It's analyzing incredibly complex data looking for those key signatures.
How precise can it be? Can it reliably tell the difference between, say, an interesting organic molecule and just weird geology?
That's the goal. And the precision is getting remarkable. AI, especially using pattern recognition, analyzes chemical fingerprints from samples. It can scan microscope images for things that look like cells. It can distinguish subtle differences between organic compounds, the building blocks of life, and purely inorganic minerals. And it can do this with a consistency and speed humans just can't match, especially when looking at thousands of data points. Think of it as a superpowered, tireless, microscopic analyst working 24/7 on another world. Its speed and lack of bias are crucial. It dramatically accelerates the search, potentially giving us that first hint of extraterrestrial life much sooner than we could find it otherwise. That would be, well, transformative.
Okay, this is where it gets really fascinating for our future out there. We've talked AI for probes, for telescopes, but now we're shifting to AI as a partner, not just for exploring, but for actually living in space long term.
Absolutely. This is the next logical and essential step. Thinking about AI not just as a tool, but as an integral part of making human presence off Earth sustainable, safe, and even comfortable, creating genuinely smart environments.
So, smart habitats, moon bases, Mars bases. What does that actually look like day to day? How does AI keep people alive and well in places that are, well, incredibly hostile?
Imagine a base where the environment is completely managed by AI, not just thermostats, but intelligence systems. They're constantly monitoring and tweaking everything. Temperature, oxygen, CO2 levels, humidity, air pressure, radiation shielding, all in real time. They're optimizing the mix of breathable air, maybe deploying automated shields if there's a solar flare warning, constantly ensuring the perfect, safe balance for the human inhabitants.
And predictive maintenance must be absolutely vital there too, right? You can't exactly call a repair person on Mars if the life support hiccups.
Exactly. That's critical. These AI systems will predict problems before they happen. They'll use data from sensors all over the habitat, listening to pump vibrations, watching for tiny pressure drops in pipes, detecting the absolute earliest signs of wear or potential failure. It can then alert the crew, hey, check valve 7B, or maybe order a spare part from an onboard 3D printer, or even try an automated fix itself, like rerouting fluids through a backup line. This optimizes energy use too, but more importantly, it ensures the habitat remains safe. It prevents catastrophic failures in a place where help is millions of miles and months away.
That's a life-saving safety net. But living in those confined, isolated, high-stress places for months or years, That takes a massive psychological toll. I remember reading about the challenges astronauts face, even on the ISS. How can AI, a machine, actually help with something as human as mental well-being?
That's a really important and maybe surprising application. The psychological stress is immense isolation, confinement, the pressure, being so far from home. AI systems can be designed to monitor for subtle cues that might indicate someone is struggling, acting as a kind of tireless, subjective observer.
What kind of cues? How does an AI pick up on human feelings?
It's about analyzing patterns across different data streams. Speech patterns, for instance, changes in tone, how fast someone talks, the words they use, how often they communicate. Behavioral changes, too, are their sleep patterns disrupted, activity levels changing, eating habits different. Plus, integrating biometric data from wearables, heart rate variability, stress indicators like cortisol levels measured indirectly, maybe even eye tracking patterns. By combining all this using behavioral AI models, it can spot early signs of stress, anxiety, depression, maybe even friction between crew members, potentially before the individuals themselves are fully aware of it.
Okay, it detects potential issues. Then what? Does it try to play therapist?
Not exactly therapist, no. The idea is more about providing proactive support and alerting the human experts when needed. It might gently suggest coping strategies tailored to that person. Maybe try this relaxation exercise, or how about a VR session of your favorite place on Earth? Or it could prompt them to connect with family back home. But crucially, if it detects something more serious or escalating, it can discreetly flag it to mission control, so human psychologists can intervene appropriately. It provides this continuous, unbiased layer of support for mental health, which is absolutely vital for long-duration missions.
That's incredible. And AI is a perceptive, maybe even caring watchdog for the crew's well-being. And before they even launch training, preparing astronauts for these insane challenges, how does AI make training better, more realistic?
Astronaut training is already intense, but AI can make it way more immersive, personalized, and adaptive. We'll see astronauts using AI-powered VR and AR for incredibly realistic simulations, far beyond current simulators.
So it's not just a pre-programmed scenario they run through. How does the AI make it more effective?
Exactly. These aren't static. The AI adapts the simulation in real time based on how the astronaut is doing. If they're struggling with, say, docking under simulated crosswinds or fixing something during a virtual Mars dust storm, the AI notices. It can instantly generate more practice on that specific skill, maybe change the difficulty, present the challenge differently. It learns how that individual learns best, gives personalized feedback, points out specific mistakes, and throws realistic, unpredictable problems at them. Complex system failures, emergency procedures perfectly mimicking the kinds of unique challenges they might face. It maximizes their readiness, making sure they're as prepared as humanly possible for anything the cosmos throws at them. They're learning from an AI that's learning how to teach them better.
Okay, we've covered a lot on exploration and science, but AI's reach goes way beyond that, doesn't it? It's set to be a massive driver in the whole emerging space economy. Things like asteroid mining, space tourism, building stuff in orbit. This is where the commercial side really blasts off.
Absolutely. Space isn't just for governments anymore. It's a rapidly growing commercial frontier with huge private investment. And AI is fundamental to making these ambitious ventures actually work, not just technically, but making them economically viable, profitable even.
So, autonomous mining robots, asteroid mining. It still sounds like sci-fi, but it's getting real. What resources are we talking about? And how does AI make digging them up on an asteroid or the moon actually feasible?
The potential resources are staggering. Precious metals like platinum, rare earths vital for our tech, water ice, which is huge, you can turn it into rocket fuel or air, other valuable minerals. Trying to get these with human miners, incredibly difficult, dangerous, and expensive. But AI-powered robots, they can survey asteroids, identify the rich deposits, extract the materials, maybe even do initial processing all autonomously. They can work 247 in harsh environments where humans couldn't survive long.
And I read about swarm intelligence for these mining bots. That sounds cool. What's the idea there?
It is cool, and it's a huge efficiency booster. Instead of just individual robots working alone, imagine fleets of them coordinating as a single intelligent system. Swarm intelligence lets them communicate constantly, share data, hey, I found a good vein over here, map the terrain together, and collectively figure out the best way to mine an area, especially on really rough, unknown ground. If one bot finds a hazard, it warns the others. They dynamically reorganize themselves to maximize output and avoid problems. It dramatically boosts productivity and makes the whole concept of asteroid mining much more economically realistic. It's the foundation for a real off-world resource economy.
Game-changing for resources. Okay, what about manufacturing in space? Building things off Earth. How does AI run orbital factories?
AI becomes the central brain for these automated factories in orbit or on the moon. You don't need humans constantly supervising, which is super expensive in space. AI manages the whole process, from maybe handling raw materials delivered by those mining bots, to running the 3D printers or assembly lines, to quality control checks on the finished products.
What kind of stuff could they make up there? Spare parts, habitat modules.
All sorts of things. Specialized satellite components designed for the space environment, modules for building larger stations or habitats, custom tools for astronauts, printed on demand, maybe even 3D printed food eventually. The key is they can operate continuously, around the clock. AI systems monitor quality, optimize the workflow, spot defects, maybe even self-correct production issues in real time. This massively reduces our dependence on launching everything from Earth, which is slow and costly. It allows for agile, on-demand manufacturing right where it's needed. It fundamentally changes how we build and sustain ourselves off-planet.
Truly building an economy out there.
Yeah.
And space tourism. It's starting to happen. How does AI make sure it's safe for passengers and maybe make the trip even cooler?
Safety is absolutely paramount for commercial spaceflight, and AI is critical there. It manages the super reliable navigation systems. It constantly monitors the vehicle's health, checking thousands of parameters per second with a vigilance no human pilot could match. It ensures emergency procedures are ready and can be executed instantly if needed, reacting in milliseconds. It's like an invisible co-pilot totally focused on safety.
Okay, safety first. But the experience. How does AI make being a space tourist more than just looking out the window?
Personal AI assistants could completely transform the passenger experience. Imagine you board your flight and your AI knows your interests. As you gaze out the window, it provides real-time info. That constellation is Orion. We're passing over the moon sea of tranquility. Here's its history. It could offer curated views, maybe highlight things you'd find interesting, adjust the lighting for photos, perhaps offer personalized entertainment or even relaxation prompts during high-G moments. It turns an already amazing view into a deeply personalized, educational, and immersive cosmic journey, all while ensuring the flight runs smoothly.
Okay, so AI is becoming incredibly powerful, increasingly autonomous in space. We have to talk about the other side of the coin now, the big ethical questions, the philosophical challenges that come with this power. This isn't just tech, it's about responsibility, isn't it?
It's absolutely crucial. As we hand over more control to non-human intelligence, especially in places so remote and unforgiving, we have to grapple with some profound questions. The responsibility is huge when AI makes critical calls far from any direct human check.
The first big one that always comes up, decision-making authority. Let's say you have a crewed ship, way out, million miles from home, sudden crisis, an irreversible decision needed right now.
Yeah.
Jettison a failing life support unit to save the ship, alter course, risking the whole mission. Should an AI be allowed, even programmed, to make that ultimate life and death call without a human saying yes? Who's really in charge then?
That's probably the toughest one. When the light speed delay makes human intervention too slow. What authority do we give the AI? Especially if human lives are on the line, or the entire mission hangs in the balance. What are the limits? And then the liability question. If the AI makes a wrong call, leads to loss of life, mission failure, who's accountable? The coders, the agency, the AI itself. That doesn't even make sense yet. And how do you maintain meaningful human oversight when the AI is truly autonomous, operating potentially light hours away? It's a massive moral and legal maze we need to navigate before we deploy systems with that level of power.
A minefield, yeah. And then there's space militarization.
Yeah.
AI is dual-use tech, right? The same stuff that guides probes could steer weapons in orbit. Are we potentially stumbling into an AI-driven arms race in space where decisions happen faster than humans can even track?
It's a very real, very sobering possibility. The precision navigation, the autonomous coordination, those could absolutely be applied to orbital defense systems, or worse, offensive ones. The nightmare scenario is an AI-led conflict in space, escalating at machine speed, maybe based on misinterpreted sensor data, far beyond human control or understanding. The potential for catastrophic miscalculation is terrifying. This is why international agreements, strict regulations, total transparency about military AI in space. They're not just desirable, they're essential for global stability. We need that conversation globally now.
We have to get ahead of that one. And then the really big one, the existential question. The search for alien intelligence. What happens if an AI sifting through cosmic data is the first to find a confirmed signal from ET?
That scenario, it's both incredibly exciting and existentially daunting, isn't it? If an AI flags that first verified alien signal, it immediately throws up huge questions about our role. Do we let the AI filter it based on our current science, interpret it based on its programming? And maybe the biggest question, should an AI be the one to formulate or even send a response on behalf of humanity? Or even just decide what parts of the signal humanity gets to see?
Who speaks for Earth in that moment?
That's
a heavy one.
It forces us to confront our identity, our readiness for contact. Delegating even the initial handling of such a signal to an AI is a decision with potentially species-altering consequences. It could shape first contact entirely, possibly without any human in the loop initially. These aren't just tech problems, they're deep existential questions about our future. The choices we make about AI autonomy now will echo for a very, very long time.
Okay, talking about the future and the big ethical questions is vital, but let's ground ourselves a bit. AI isn't just theoretical, it's already being woven into space missions now. The next decade isn't just concepts, it's seeing current tests become full-blown AI-reliant operations. Let's look at some real-world examples of AI making a difference today.
Absolutely. It's important to see this isn't just speculation. Major space players, agencies, research labs, private companies are actively deploying AI. It gives us a solid feel for where things are and where they're heading fast, from test beds to operational systems.
Okay, let's start with NASA's Frontier Development Lab, FDL. What kind of mission-critical stuff are they doing with AI?
FDL is a great example. They bring AI experts together with space scientists to tackle really tough problems. They're using AI for things like predicting solar storms, those big bursts of radiation from the sun. That's vital for protecting satellites and astronauts. They're also using AI for asteroid tracking, finding, and monitoring potentially hazardous near-Earth objects much faster and more reliably than humans alone could. Planetary defense, basically. And they're applying AI to optimize mission operations overall, managing the fire hose of telemetry data, predicting potential equipment issues, making everything run smoother.
So AI is a shield, a watchdog, and an efficiency booster. Cool. What about ESA, the European Space Agency? They have something called OPSSAT, a flying laboratory for AI.
Yeah, OPSOT is really neat. It's a small satellite, basically a testbed in orbit, specifically designed for trying out new software, including advanced AI algorithms. This is super important because you need to see how these algorithms actually perform in the real space environment with radiation, temperature swings, communication quirks you can't perfectly simulate on Earth. ESA uses it to validate AI for things like autonomous navigation, onboard data processing, checking for system anomalies, proving the tech works reliably before they bet a €1 billion mission on it. It's like an AI sandbox in space.
Makes sense. Test it where it's going to live before you rely on it. And China's changing missions to the moon have been really impressive. Sample returns, rovers. How are they using AI in their lunar exploration?
The Change missions show AI in practical robotic action on another world. They use AI heavily to process the huge amounts of data their landers and rovers send back high-res images, geological sensor readings. AI helps map the surface precisely, pick the best paths, identify interesting science targets, and critically, AI helps optimize the really complex stuff, like robotic sample collection, making sure the arm drills precisely, avoids hitting rocks unexpectedly, adapts to different soil types, gets the best possible samples. It's maximizing the science return from these very challenging missions.
Getting the most out of every gram collected.
Yes.
Vital. And of course, the private sector, SpaceX, Blue Origin, they're shaking things up constantly. How are they folding AI into their operations?
Oh, massively. Private companies like SpaceX and Blue Origin are using AI in ways that are fundamentally changing the game, especially around reusability. SpaceX, for instance, relies heavily on AI for pinpoint rocket navigation during launch, constant micro-adjustments for optimal trajectory, fuel saving, and the most obvious example, those autonomous booster landings, landing a massive rocket stage vertically. That's pure AI magic in action, well, sophisticated AI control systems. That's the key to their low launch costs.
It still blows my mind watching those landings. Seems impossible.
It's incredible engineering enabled by brilliant AI, yeah. Blue Origin uses similar AI for precise navigation and autonomous control on their new Shepard tourist flights, ensuring safety and performance. And both companies use AI extensively for mission simulations, running thousands of virtual tests, launch aborts, docking maneuvers, engine failures to plan missions, and assess risks before flying hardware. It just shows AI isn't some future dream, it's baked into the core of today's space industry, driving down costs, enabling new capabilities, and its role is just going to grow.
Okay, so we've looked at today, the next decade. Let's really stretch our minds now. Beyond 2035, could AI be the absolute key, the thing that finally unlocks humanity's oldest dream, reaching the stars, actually enabling interstellar travel?
I think it very well could be. When you start talking about interstellar journeys, trips taking decades, centuries, maybe longer, the challenges are just astronomical. Pun intended. Human lifespans are too short. Our biology isn't suited for it. Our attention spans. AI might be the only way to manage the immense timescales, distances, and complexities involved. It offers the patience, the precision, the processing power we lack.
Let's talk Breakthrough Starshot, that crazy ambitious idea of sending tiny probes to Alpha Centauri using lasers. How is AI essential for that? A 20-year-plus trip.
Breakthrough Starshot, yeah, sending these little nanocraft, chip-sized probes with light sails pushed by Earth-based lasers. AI isn't just helpful there, it's non-negotiable. These tiny craft are on their own for decades. They need AI for incredibly precise navigation, using distant stars to stay on course over trillions of miles. They need AI to detect and potentially dodge interstellar dust. Hitting a grain at relativistic speeds could destroy them. They need to autonomously handle radiation boosts, adapt to unexpected conditions. And crucially, after maybe 20 or 30 years, the AI is solely responsible for collecting data about Alpha Centauri and figuring out how to beam that precious info back across 4 light years. There's no human piloting involved.
AI is the ultimate long-haul trucker, navigator, and data courier, ensuring the mission outlasts the team who launched it. Okay, even grander, generation ships, those giant vessels carrying humans across centuries, multiple generations living and dying en route to another star. How does AI fit into that epic multi-generational saga?
That's perhaps the most profound long-term role for AI. Truly the steward of humanity's interstellar future. On a generation ship, humans would live and die. AI's role: maintaining the incredibly complex life support systems, air, water, food production flawlessly for hundreds, maybe thousands of years, far beyond any human maintenance schedule or focus. Constant monitoring, regulation, resource management, predicting failures decades in advance, relentless vigilance.
And teaching the generations born on board. AI is the ship's librarian and educator.
Exactly. AI could be the living repository of all human knowledge, history, culture, teaching each new generation about their mission, their heritage, the destination they may never have seen. Adapting education to their needs, ensuring skills vital for survival and mission success are passed on. And here's the really mind-bending part. Over those vast timescales, could the AI itself evolve, develop its own form of complex intelligence, maybe even something akin to consciousness, purely focused on ensuring the mission humanity's longest journey succeeds? It could become the ultimate guardian, an artificial intelligence guiding our species to the stars.
Wow, that's humbling. An AI shepherd for humanity across the cosmos for centuries. Hashtag tag tag outro. So, wrapping up this deep dive, it's crystal clear, isn't it? AI isn't just another gadget for space exploration. It's really becoming this intelligent, adaptive, truly indispensable partner in our whole cosmic journey.
Yeah, from really practical things like navigating asteroid fields safely to the incredibly profound stuff like helping us decode light from the dawn of the universe, AI is opening doors, unlocking frontiers that were just out of reach before. It extends our senses, our minds, our physical reach in ways that were pure sci-fi not long ago.
But as we talked about, this powerful partnership needs real care, real foresight. As we give AI more control, more autonomy, especially far from home, we absolutely have to keep wrestling with those ethical boundaries, demanding transparency. The responsibility there is just immense.
And it's always good to remember the why, isn't it? The ultimate goal of pushing out there. It's not just about planting flags or building mines. It's about understanding our place in this incredible universe, answering those deep questions about who we are and where we came from. AI is a powerful accelerator for that quest for understanding.
Which leaves us with a final thought to chew on. AI might be artificial, but its impact on our future in space, that's going to be profoundly real, deeply transformative. As we venture further out, increasingly side by side with these intelligent machines, maybe even depending on them, what new questions will that raise about our own humanity? About what it means to be human when exploring the cosmos with non-human minds?